Hey Charlotte, so I started off recording this video for you, and then I realized how you had your questions arranged, and so this might be a little bit wonky to try to find all these the way you've labeled the numbers on here, but I'm gonna do my best. Okay, so for this one, I went ahead and set it up. What you see now is pretty much the work that you are gonna be expected to show. And the answer is kind of already in here, so we can make sure that we got it right. So for this type of problem, they give you the coordinate and they tell you, okay, 6 comma negative 6 comma negative 6. That terminal side of that angle, slices right through that point. So we can use that information here along with the sort of right triangle building of sine here, or not quite the right triangle, but in any case, we can build sine like this with y over r. So using these two things, we can go ahead alongside of determining r with the Pythagorean theorem, go ahead and set this thing up. So I went ahead and substituted in negative 6 for x squared and negative 6 for y and the y squared, and wound up with 72. When we simplify this is 36 times 2, so it's going to be 6 root 2 as r. Now, this terminates in the third quadrant, and in the third quadrant, both x and y are negative. So when we plug these in, just make sure we're plugging in negative 6 for y, and then we're plugging in 6 over the square root of 2, 6 times the square root of 2 for the denominator. The 6's will cancel, and what you're left with is negative 1 over the square root of 2. We need to rationalize the denominator here. So once we do that, we end up with negative root 2 over 2, which is the answer that you see there. All right, so the next one that you have is 5.2.45. Let me see if I can find that real quick. I think it was up above, but I'm going to keep scrolling down since I'm in this direction. 5.2.39. Okay, so it's all the way up. Let's go up to the top and see if we work our way down. 5.2.45. I could have swore I just saw it. 5.2.45. And like I said, this is kind of, there we go. So this whole one is the one you're talking about right here. And it's, this is an interesting question. But pretty much what you need to do is convert what you have here. You need to convert that into slope-intercept form. So if I did that really quickly, starting the process, I would end up with 6y is equal to negative 3x. And then ultimately that y is equal to negative 1/2 x, right? Also, we have to note that x, whatever x we use for this, is less than 0. So just keep that stuff in mind with this particular type of problem. All right, so what I normally do is I will select an x value that matches the denominator. But since x needs to be negative, I would select negative 2 there. So I would let x equal negative 2 to see what y equals. So when x is negative 2, and let's plug that in real quick. When x is negative 2, these cancel, the 2's cancel, and y is just equal to 1. All right, so that information right there gives me everything that I need. That tells me we are going to be in the second quadrant, because in the second quadrant, x is negative, but y is positive. So we can definitely eliminate B here. It's going to be between C and A. Now, let's think about it for a second. When you're looking at these two angles here, one is more obtuse than the other. All right, and in the second quadrant, the more obtuse angle has a larger x value than it does y. What I mean is this point here, if we were to like, you know, write the ordered pair of that point, looking at the x's, would be like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, like negative 6, comma, 1, 2, 3. All right, so this is more in line as to the ordered pair that we have, because we have negative 2 comma 1, so the x is definitely greater than the y. Whereas up here in this example, what you'll notice is that it's just the opposite. Like the x is negative 3 and the y is 6. So if you take the absolute value of those things, you'll see that the y is greater, right? That's not the situation we have, which is why C is the correct answer here. Moving on, we just need to define each of our trigonometric functions. Since we have x and y, you can find r. And once you find r, you pretty much have this problem done. So that's going to be negative 2 squared plus 1 squared. So this ends up being the square root of 5 for r. And you can determine each one of these trigonometric function values based on how they're built. So sine is built with y over r. So we'd plug in y. Y was 1. R was 5. Once we rationalize that denominator, we would end up with the square root of 5 over 5, which is what you see here for this answer. So you just need to do that for all of these. Like, for example, cosine is built with x over r, so on and so forth. 5.3135. Let's go up and see if I can find 5.3135 really quickly. I wonder if I can search. I don't know if it'll actually. It might find it. If it finds it, then this is the best. Nope. I was about to say this is about to be the best notebook that's possible, but nope. It's not smart enough. Let's find 5.3.135. 5.3.135. Come through. Where you at? There we go. Love it. Here for it. When an automobile travels uphill or downhill on a highway, it experiences force due to gravity. This force is in pounds is called grade resistance, and it's modeled by this equation here. Great. What was the grade resistance of a 1,900-pound car traveling on a 2.9 degree uphill grade? And it says the grade resistance is 96 pounds. Well, F represents the grade resistance, right? It doesn't represent the weight of the car. Yeah, it's because it says W is the weight of the automobile. They gave us the weight of the automobile. So this is going to end up being 1,900. And it's going to be multiplied by sine of 2.9 degrees. Now, the big thing to point out here is you want to make sure that your calculator is in degree mode. If you notice, I'm in radian mode, so I need to switch over to degree mode before I even do this. I'm typing in that 1900 sine 2.9, and let's just see what I get. All right, I get 96 point blah, 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 but it wants me to round to the nearest whole number. So if I round to this nearest whole number, that is how I get 96 pounds. All right, nothing too crazy there. Let's go 5.3.137. It must be down because I didn't see anything like that up. Here we go. This is the same sort of situation. The only difference this time is we're given both the weight of the car and the grade resistance. So you need to substitute those things into the formula. The grade resistance was negative 240, and this is going to be equal to 3,360, and it's going to be times sine of something that we don't know, right? So we need to divide both sides by 3, like 3360. I don't know why that word is, why that number is hard for me to say today. And we get sine theta is equal to negative 240 over 3,360. All right, we can actually cancel those zeros if we want to. Now, at this point, you just need to take the inverse sine of what you have there, and let's just see what our calculator says. They want it in degrees, so you want to make sure that your the calculator is in degree mode. So I'm going to take the inverse sine of negative 240 divided by 3360. And I end up with negative 4.096 and some change. They want me to round to the nearest hundredth. So if I round that to the nearest hundredth, this is going to give me negative 4.1 like they have there. So, I'm going to go ahead and write this here. I got a negative 4.096. Or like they wanted, negative 4.1. All right, that was that one. We're halfway through. 5.4.75. I could have swore I saw it up, so I'm going to go up. 5.4.75. 5.4.75. I'm looking for you. 5.4.75. 5.4.75. Where are you? 5.4.25. 5.4.75. We're looking for you. 5.4.75. This is the tedious process right here. Let's go all the way down to the bottom. Let's try from the bottom to the top. There we go. All right, so what a question. What a question. In fact, yeah, let's just do it. I don't care. So it says the bearing from city A to city B is north 56 degrees east. The bearing from city B to city C is south 34 degrees east. In an automobile driven at 55 miles per hour, it takes 1.8 hours to drive from city A to city B, 1.2 hours to drive from city B to city C. How far away is A to C? And we want to ignore the curvature of the earth. Now, this is in 5.4. We haven't really learned the law of sines yet. So the law of sines, just because I've seen this movie before, right? The law of sines is going to allow us to solve triangles that are oblique, meaning they are not right. Pretty much, this is going to form a right triangle. It just has to. We're just in that section, right? So let's just try to set this thing up, okay? First things first, go ahead and get a point. And then within that point, I like to use Cartesian planes because they help me keep track of my angles and things like that. So I can generate my angles a little more accurately. Now, this is city A because this is where it all starts from. So we're going to go to city B. Now, city B exists on a east to west, or not east to west line, but a bearing of north 56 degrees east. So 45 degrees or something like that. I'm just going to add a little bit and pretend it's 50. And they drive for 1.8 miles. So we're just going to say that's the arbitrary distance that it takes to go from A to B. All right, you can never be super precise here, but you just do the best you can. Now, I want another one of these Cartesian planes. Like, these things are good for me. I appreciate them, so I'm going to summon me another one for the city at B. Now at B, this trip they're gonna go south 34 degrees east, so towards the east. This is 45, not quite 45. So something like 35 or something like that. All right, and they're going to go for less time, but it's still there. And then what they want us to determine is, and let me go ahead and put C down here. So this is C. And what they want us to determine is the distance from A to C. I don't want that color. There we go. They want us to find the distance from A to C. All right, so let's extend these out a little bit. This is going to help us with the what's called an angle budget analysis here. We can even do it at C if we need to. I don't know if we need to just yet, but I'll go ahead and make one just in case. Now, the bearing here is going to be 56 degrees. So that's 56, right? Now, due to what's called a transversal problem, so we have two parallel lines that are running here north and south between A and B, and this line is a transversal that crosses through them, right? So that transversal creates pairs of congruent angles. So this angle here is congruent to the angle that's created there, all right? Now that's going to help us because we know this is 56, and then when we start to analyze the other budget, I'm going to go ahead and guess that up here, that corner of B is going to be a 90-degree angle. And if we have a 90-degree angle, we can solve just about anything. So let's think about our budget here for B. The bearing for B was south 34 degrees east. So this is a 34-degree angle there, all right? Now, that's useful to us because, again, 56 plus 34 is 90. So we have a whole 90-degree angle, or right angle here in this corner, okay? Now, let's take a look at what we got going on here. So they want us to find distance. And by the way, the formula for distance is rate equals time. They want us to find distance, and they give us the rate, and they give us the amount of time, all right? So then we can calculate the distance for both of those. And we can calculate the distance for both of those because the rate is consistent, all right? The rate is 55 miles an hour. So the distance from A to B, it takes 1.8 hours at 55 miles per hour. So 55 times 1.8 is 99 miles. So this distance here is 99. All right. The distance from B to C is a little less, so that's 1.2 hours, so 55 times 1.2, that's 66 hours, or 66 miles, rather. Now, and we don't know this, right? Since this is a right triangle, and we know two of the lengths, we can use the Pythagorean theorem. So the Pythagorean theorem says C squared is equal to A squared plus B squared, where C is the hypotenuse, and the hypotenuse is opposite that of the right angle. So the C that we're looking for is the hypotenuse, or the side we're looking for is the hypotenuse. So we can go ahead and just, this looks very familiar to some stuff I've already shown you. Here is the Pythagorean theorem. We just substitute in 99, substitute in 66, and let's see what the approximate distance is from A to C. So I'm going to go ahead and take the square root of 99 squared plus 66 squared, and that gives me 118.983 miles. Now let's look and see how they want us to round this real quick to the nearest mile. So that's going to be 119. All right, luckily this is a video, so you can stop and replay it however you would like. 6.1.107. Let's go down to the bottom. We're already close to there. So 6.1. There we go. All right, so here's an area of a sector sort of situation here. This is from 6.1. I'm not gonna lie, I need to go retrieve that. I'll need to go retrieve that that formula for the area of a sector. There we go, area of a sector. So that's gonna be 1/2 r squared theta, where theta is in radians. 1/2 r squared. And these are the slides that I gave you. So 1/2 r squared theta. All right, I'm just going to substitute in that information. Now theta needs to be multiplied by pi over 180 because it is in degrees, and it needs to be in radians. My calculator also, you're going to want it to be in radians. So 1/2 times 20 times 120 times pi over 180. So I get, and luckily the answer is covered up, so I don't know if this is right or not, but I get 20.943. That is not right. Oh, I didn't square 20. Well, that's a very organic golden mistake that you got to witness. Hopefully my mistake doesn't allow or helps you no longer make that mistake if you made that mistake. So that's 20 there, and then it's like 120. She's like, my teacher doesn't know how to math. Hey, we all don't know how to math sometimes. All right, and I get something that's much more appropriate. 879, and this is square miles. They want us to round to the nearest tenth, so that's how they get 418.9 square miles. I lost the screen that had all your stuff. Give me just a second. All right, so that was 6.1.107. Now 6.3.27. Let's just continue to scroll up. Maybe we'll find it. We're also looking for 6.3.33. I'll do whichever one comes first. Do I see a 6.3? Nope. Let's scroll on down. $27 and $33, $27 and $33, $27 and $33. There's 27. What's the period of this function? Awesome, love this problem. One of my favorites. So let's think about how trigonometric functions are like the parameterization of trigonometric function. So it's going to be a sine of bx, bx plus c, and this is plus d on the outside, right? So that's pretty much what we have going on here. So when you look at this, like c is 0, a is 1, d is 0. So the only thing that you have is b. So b is the thing that we're looking at here. Let's talk about the period of a function. Period of a function is defined by omega equals 2 pi over b. That same b we were just looking at. What's the b in this function? 6. 2 pi over 6. 2 goes into 6 one time. 2 goes into 6 3 times. Or you can write it as 1/3 pi like they did, but that looks so tacky. It's all good though. Pi over 3 is my favorite, but you do whatever you need to do for my math lab. What's the amplitude of this function? Well, look at A. What's A in this case? Do we see an A here? Nope. That means A is equal to 1. If A was equal to 0, the whole thing would be gone. Now, which of the following is the correct graph where there is no horizontal or vertical translation? Because horizontal and vertical translation are controlled by these parameters, and we see neither of them present in that function that gave us. So this thing is centered at the origin, and it's a sine function. So where does sine begin? Well, sine, oh my word, OneNote is acting up. Sine, oh come on OneNote, don't do this to me. Not in public. All right, let's see if OneNote will cooperate with me this time. Pretty please. Okay. You're doing all right. Let's expand this. Okay, finally, we got this thing to work. So you can always consult with the unit circle to determine where sine begins, because sine is y-based based on circular functions. X is, to give you the whole thing, r cosine theta, and y is r sine theta. Okay, so sine is y-based. So if you look at where these things start here, the starting point is going to be at 1, 0. So since cosine is x-based, cosine starts at 1, and since sine is y-based, sine starts at 0. So when I'm looking at these graphs, I'm looking at the origin, I'm looking for our function to start here at 0. Luckily for you, they didn't give you any any cosine one, so you don't really have, you're not able to eliminate anything. You have to know what's going on, but we're here for that, right? So where does sine go? Well, after the first sort of quarter rotation, sine goes up here. What are these points? These points are now 0, +1. So sine increases first when there is no reflection. So we're looking for everything that increases first. So this does not increase first, it decreases first. This decreases first as well. So it's something to do with B or C. Now, another thing we can take a look at is amplitude. Take a look at that amplitude there. The amplitude for part C goes all the way up to 2. If amplitude went all the way up to 2, then that would indicate that A must be something like 2, or, there must be some sort of vertical translation for that to happen. But we know that the typical output of sine is going to be between -1 and 1. So then this amplitude for B seems adequate, and that's why B is the correct answer there. Got one more, and that is going to be 6.3.33. 6.3.33, and I'm here for it. It's the same exact thing, just different. And now this time, we have a cosine function. Luckily, we've already written out the parameterization for cosine, or sine, and cosine are the same. So let's just write cosine this time. That's A cosine bx plus c plus d. It's actually bx minus c. You always really want to be subtracting in the argument. I wrote plus, but silly me. You always want to be subtracting in the argument. So we have cosine of 6 pi x. So in this case, B is actually 6 pi. All right, so that's B this time. Now, it's the same thing with determining period. It's just omega is equal to 2 pi over B. So we have 2 pi over 6 pi this time. The pi's cancel. 2 goes into 6 once, or excuse me, 2 goes into itself once. It goes into 6 3 times. So that's how we get that period. is not negative. That little slash does not indicate that it's negative. This is positive. Amplitude, we're still looking out in front for that amplitude. Amplitude is 1. We already talked about how cosine starts. In fact, I can just go up to that diagram. Cosine always starts at 1 unless there's some type of reflection or translation occurring. There is neither of those happening. So the cosine that we're looking for should start up at y equals 1. So we can eliminate B and D on the principle that they are both negative. That's 1 there. Is this 1, 2? No, so that's a 2. So then half of that should be right here. So we could eliminate A, which makes C the correct answer. That's much easier of a problem. So I hope this helped. Feel free to rewind. I just wanted to kind of scrunch all of these in, and hopefully that can give you a little bit of an understanding for your midterm. If you've already taken your midterm, then maybe it can give you some understanding about the questions that you potentially missed. So have a great day. Let me know if you need anything else. Peace.